Let me just set this up. Okay, thanks for the opportunity. So just to introduce myself, and for those that don't know me, Daniel Swinnerton, Managing Director of Prime Projects. Prime, we're a head contractor, we're a builder. We specialise in industrial and commercial developments. And full disclosure on this case study, I mean, we're not aligned with any steel or timber associations or manufacturers. We're simply just a builder and wanting to be part of the solution in decarbonising these assets. So we had a couple of case study partners. In this case study, we had Griffiths Engineers Australia assist with some structural engineering. We had BG&E do the initial timber designs. We had Savcon refine those timber designs on a D&C component. WG3 helped us with some of the costings, and sustainable development consultants did a lot of the grunt work on all the LCA data crunching and info. Okay, so the challenge, the why. It's well known, and it's, you know, the challenge we're facing in decarbonising the industry, especially industrial buildings, and I think it's what's driving a lot of the MECLA members. But decarbonising industrial assets is a bit of a tricky one, and a little bit more challenging than some of the other asset classes, due to the building's performance requirements and the materials that make up that in terms of large spans, large loads, and what those materials can do. If you look at the pie chart that sits there, it's a typical embodied carbon makeup of an industrial building, where you can see typically two thirds sit in concrete and steel, which is basically all these buildings are, really, really large garden sheds with a super high performing floor and clear spans so you can move around inside them. Then if you look at, and what was the main driver for me is looking at these Green Star carbon reduction targets. So currently you need 20% reduction for a 5 or 6 star rating. In 2026, that ratchets to a 20% reduction for all registrations, with the 6 star needing 40%. And then what scares me is the stretch target in 2030, where all registrations will require a 40% reduction. So the project itself, in May this year, we completed construction on a pretty typical warehouse for Fife Capital out at St Mary's. Pretty stock standard, 10,000 square metre warehouse. You can see in the photo, clear spans over a high performing floor. We had a 2-storey office at the front, a little dock office, an awning where logistics occur, and then hard stand concrete and a car park out the front. So given that we just finished this building, we were well aware of what went into it. We were well aware of how much it costs. And we thought we'd take the opportunity off that data that we had to then try and run some scenarios about, righto, there's this 40% target. How would we get there? What could we do? Keeping in mind that building that we did hand over had no Green Star rating, no decarbonisation requirements whatsoever. Again, we've taken that data, look at the pie chart there, 42% makeup of concrete, 28% of steel. What levers can be pulled to reduce the embodied carbon? So obviously there's build less, which you hear get thrown around a bit. And that's pretty hard for a developer not to maximise his floor space ratio and in turn his returns on his development by building less square metres. There may be some juice sitting in and around, you know, contingency factors in standards now that materials performance has improved. Can we reduce some of these contingency or safety factors? That's probably a separate conversation. And the other two levers, as we see it, is material substitutions or current material improvements. So we thought about, what if we went down the path of substituting the structural steel for timber? So timber warehouses aren't a new thing. There's a couple floating around. The photo on the left is my timber at Penrith, which was probably built, I don't know, 10, 15 years ago. I know that Goodman have just about or have completed a timber warehouse in Victoria. And then the photo on the right, you can see is the same bits of warehouse, but now in a timber format. So the levers we pulled from the base design. So we replaced the structural steel elements with structural timber elements within the warehouse. We replaced the precast concrete panels to CLT panels to the cores within the office, and you can see on that little snapshot on the right there for the lift and the amenity core. We replaced conventional reinforced concrete slabs to the office with CLT flooring. We replaced the structural steel roofing to the office with CLT roof panels. And we replaced the precast dado wall panels to the warehouse with just metal wall cladding. And then in terms of the improvements, we then introduced all our carbon reduced concrete mixes. So our first pass of the designs on the left-hand side from BG&E, and that looked at 100% timber substitution. And you can see, if you can squint, some of those structural elements are massive. You know, you're looking at a 1600 wide perimeter column there. And the internal columns there are 450 squares. Glulam beams are 960, so some pretty heavy elements there. We took that as the base design. We then workshopped that with Savcon, who are a D&C provider, and they looked at a hybrid model. So if you can kind of see from our model, you've got the awning stays and you've got the internal columns that remain structural steel, and all the other elements are timber there. And they also looked at the efficiencies from a feasibility and install standpoint with timber sizing, you know, containers, what's getting shipped out here, how it's going to go together to give us a proper overall picture. So where we landed, our perimeter columns, typically 530, 610 UBs, have gone to a 900 glulam. The rafters, 410 to 610 UBs, have gone to a 900 glulam. Our purlins gone from a 250 to a 400 steel to glulam, and we kept the wall girts the same in steel. And then we also kept, as I said, the awning stays and the internal columns as originally designed in steel. So the revised design impacts and considerations, increased structural profiles, so loss of storage space. That's not only in area on the floor, but you know, more importantly, in volume, given the profile depths within the roof. Impact on service designs, again, that comes from due to the structural depth. There's a you know, a circa 25% increase in sprinkler costs, how the sprinklers need to go around that depth in profile with a 400 purlin as opposed to a 250. We introduced concrete pedestals for impact protection for the perimeter columns. There's a security and impact protection issue around deleting the precast dado panels and having tin to the ground. And the photo on the right-hand side, you can see that's the Goodman project in Victoria where they did the same. But you can imagine a fork going too close to that wall cladding as opposed to a precast panel. They're two different products, really. And some of the other costs, the client expectations from a traditional industrial building, like what the tenants are used to seeing and used to operating in, would be a consideration. One of the other cost drivers is the time increase. So there's a 28-week increase in the pre-construction phase, which won't cost preliminaries from a builder's perspective, but obviously there's costs from a developer for holding it longer. Now, the timber itself is a 24-week procurement shop drawer fabrication phase, but you've got to complete a prelim timber design. Then all the other remaining disciplines need to be designed and coordinated before you get into your shop drawing phase. So it sort of protracts that pre-construction design phase. Where if you look at steel, that can be 8 weeks procurement, shop draw, fab. And you can do that pretty early on and fast track that within the design phase. And it's because it's something we're, super used to. We do shed after shed after shed, so we can make some assumptions and play on pretty quickly. And then there's a 12-week increase in construction phase with the timber not coming the same lengths as steel and having to work all that out. It's a lot slower to erect. Okay. Carbon comparison. Blue is the conventional steel design. Orange is our alternative. You can see massive reductions in concrete. You can see a fair reduction in steel. But then as you come along that bar chart, you can see the increase in timber carbon that was previously not there. And then there's a slight decrease in other, which relates to reduction in plasterboard with the office cores and that being CLT exposed. And also there's a reduction in on-site emissions, deleting the precast panel installation for the dado wall versus the metal cladding, not needing a frenner or a crane to load those panels in. So when we come back to our pie chart, we've certainly reduced concrete and steel, but the end result was a bit disappointing, really. You look at the revised design achieved a 24.11% reduction in embodied carbon from the GBCA reference case, and the additional overall cost for this revised design was 26.32. So excellent to go and pull out a quarter of the carbon, but at that cost, it's a pretty big impost. And the results can be a little misleading, because if you just take the timber component aside, it only equated to 6% of the overall carbon reduction. So of the 24.11%, we could only attribute 6 of that percent to timber. The rest was in our green concrete and deleting the precast panels. But steel was 25% of the 26% cost increase. So, breaking that down, you could decarbonise 18% for a circa 1.5% increase by only looking at pulling the concrete lever, and an increase at 1.5% is probably a lot more palatable for the developers. If you look at the industrial market feasibilities, they're already on a knife's edge, and 2% shift in building costs can make some of these projects be problematic and not proceed, let alone an impost of 26%. And noting that 20% cost uplift will still not achieve a Green Star rating. So there's little or no marketing or rent increase value for the developer in sort of spending that extra capital to get that reduction. The next steps, what else we could see from this case study? I mean, we could look at sourcing local timber products, which would have a circa 2 to 3% improvement on the carbon reductions. We could look at changing the timber product. So at the moment, we're talking about glulam beams, which are pretty aesthetically pleasing. Do we need that level of aesthetics inside a warehouse? Probably not. You could look at a plywood box beam. This would reduce the cost down 3% and improve the construction impost from 12 weeks to 6 weeks. We need to probably start looking at A4, A5 emissions aspects of the project. We need further improvements on the current materials. And when you think about this asset class, although we're looking at the structural steel, there's also a hell of a lot of metal wall cladding, and seems no real substitute. I mean, we're not going to go down the path of cladding the warehouse in CLT. Those numbers would be astronomical, but is there a substitution for wall cladding at a point in time? So ultimately disappointing with the results. We're really hoping the timber would hit the target that 40% reduction firstly, and whatever it costs, and then we could maybe work back from that point. But with 2030 around the corner, like from my perspective, which is on the coal face, I really don't see how any industrial building will be able to get a Green Star rating if that target sits at 40%. So, as I said at the top, I'm just a builder, so I'll throw to questions now. I'll try and answer all that I can, but if they're of the technical nature,